LaShawn, and I'll be presenting my project on predictive model to estimate the net hourly electrical energy output. Our data set comes from our project, and the goal is to build a predictive model that can estimate the net hourly electrical energy output of a combined cycle power plant based on the given ambient environmental readings. This is going to be a regression task because we're predicting a continuous numerical value. In this case, it would be the electrical energy output rather than a discrete category. The input features are going to be the ambient temperature, ambient pressure, relative humidity, and exhaust vacuum. The model, in this model, we're going to use these input features and map the functions to predict the output. I decided to use the Google Auto ML training as my AI, and it's the Vertex AI. So our data set contained about 9,568 samples that I split into a training and test set to train the model, one subset to evaluate the performance of another. So I have a version 1 and a version 2. The metrics I used was the mean squared error, the mean absolute error, the R squared, the RMSE, the RMSLE, and the root squared. So I use two versions. Version 1 contains all of the variables, where the ambient temperature scored the greatest importance of about 59.17%, as well as in version 2, it scored the highest importance of about 57.11%. In the training model, it took about roughly about an hour for the first and 2 hours for the second version. Fairly, the features and values were pretty much the same in comparison to version 1 and version 2, where we use both of these models. The features and attributes tell how important each feature is when making a prediction. Attribution values are expressed as percentages. The higher the percentage, the more strongly that feature impacts a prediction on average. Model features attribution is expressed using the sample Shapley method. And what that method is, each feature attribution method is based on values cooperative game theory algorithm that assigns credit to each of the features to get a particular outcome. When applied to machine learning modules, this means that each module feature is treated as an individual feature in the overall outcome or prediction. So when we compare the two versions together, we can see that the metrics provide an evaluation of the performance of each version. In general, the lower value for the MAE, the MAP, and the RMSE as well as the RMSLE. What that indicates is that this version 1 model performed just a little bit better. The R squared is closer to 1. It's not much of a difference. So that means that it's a good fit to the model data. So both of these models were pretty much a good fit, but version 1 was a little bit better. So there wasn't much difference in just using just the ambient pressure and temperature. They're pretty fairly close together, as you can see in the comparison.